We're going to start you off by trying to trigger your memory from Chapter 2. Been a little while, but solving these equations. So take a minute, solve problem 1, 2, and 3 here. I've done this before, this isn't new information. So pause it, solve these 3. Okay, assuming you paused it, you gave it a shot. Hopefully you had a moment where you went, oh yeah, what was that again? And that's what we're looking for. Either that or you just remembered. But if you look at number 1, and I'm going to work through these 3. If you work through number 1, we want to get all our x's together onto one side. So I subtract 2x from both sides. What I'm left with then, 2x's minus 2x's, 0. 2x's minus 2x's, 0. So I get that 3 equals 4, which is strange because 3 does not equal 4. So how can that be? And we had a name for that. We said that when that happens, that was a contradiction. That 3 cannot equal 4. So we said this was a contradiction. We found that most of the time we get a solution, x equals something. But every now and then it comes up where that can't happen, which means that the original equation is flawed. 2x plus 3 does not equal 2x plus 4. It was a wrong original statement. Let's look at the next one. Next one, I'm going to distribute through the parentheses. You get that 2x plus 2 equals 2x plus 2, and that should already be a bit of an indicator. But if I subtract 2x from both sides to get all my x's together, I end up with that 2 equals 2, which again seems a bit redundant. Of course 2 equals 2, that's called the reflexive property. But yeah, obviously 2 equals 2, so why do we even say it? We call that the identity. That's 2's identity. 2 is 2. That's what it is. 2 is 2. 2 equals 2. It's its identity. So we call that the identity. Last one here, we're going to solve for y. So we're just getting y by itself. These 3 skills are just ones that we really need and we want to keep reinforcing. So I'm going to get everything away from the y. We want y by itself. We need to isolate y. And there I said y and I wrote y. We would need to isolate y. It's been bad or something. It needs to be isolated. So 2y equals 6x plus 10, or 10 plus 6x. Divide everything by 2. I get that y equals 3x plus 5. Those 3 types of problems are all going to be skills that we need for this next section. And we've done this before, but these are the basic skills that we need for this section. All right, we haven't been looking at one equation, we've been looking at multiple equations, systems of equations. And so we've got the system of equations here, and we're going to graph it. So we're going to start by graphing the system of equations, and we're going to see what result we get. So looking at the first one, we've got y equals 2x plus or minus 1. That's great. That's in my y equals mx plus b form that I like so much. That gives us the y-intercept, so I can graph it. Y-intercept, -2. And it gives me the slope, which is why we like this system, because it gives us everything we need. It's abundant with gifts for us. The slope is 2. So I go from my point, rise of 2, run of 1, rise of 2, run of 1, and we can graph that line. Okay, now we look at the next one. Next one is not in a form that gives me everything I need right away, so I need to put it in that form. I need to get y by itself. Hence that first couple of questions we did. So then y equals 2x plus 1. 2x plus 1, there we go. Now I can graph it. So again, the slope, the y-intercept, 1. The slope, 2x, so 2 is the slope again. Rise of 2, run of 1. Rise of 2, run of 1. Now you'll notice if I keep going with this, I'm just never going to get an intersection point. And that's a problem. I can't solve this system of linear equations because they will never intersect. They will never intersect. And so if 2 lines are parallel, and I'm going to emphasize this too, if 2 different lines are parallel, 2 distinctly different lines, one is red, one is blue, 2 distinctly different lines are parallel, they will not have a solution. And we have a name for that. It's actually not going to be contradiction. Contradiction, I know, I just got that in your brain, contradiction, but it's not going to be contradiction. It's going to be similar, but it's not going to be contradiction. That's just with one equation. Here we have two equations that are perfectly acceptable equations. They give solutions. They're fine. They're not a contradiction. They're not a bad statement. They just don't work together very well. And we call that when two lines in a system do not intersect and are parallel, we say that that is an inconsistent system. That box there, you don't need that box. So a system that has no solution is called an inconsistent system. And I'm going to circle this as well, that they are parallel lines. And I'm going to reinforce that they are two distinctly different parallel lines. Two different parallel lines, two lines that are parallel. They have no solution. It's inconsistent. Looking back here, if I were to not graph it, now we're just going to look at this system of equations, and we're going to solve it. So I'm going to solve this system of equations without graphing. So I'm going to use those, and I'm going to use maybe the substitution method. I see here that y equals 2x minus 2. So wherever I see a y, I can put 2x minus 2. So negative 2x plus, instead of y, 2x minus 2 equals 1. So if I solve this, I see that negative 2 plus 2x, I'm going to combine my like terms here. I get 0 for that, and negative 2 equals 1. That's a problem. Negative 2 does not equal 1. I know that. And so if you see that, if you are solving a system of equations, you can graph it and see that, yep, they're parallel, they won't intersect, they've got to be inconsistent. Or you can try and solve the system by using substitution or elimination and see that negative 2 does not equal negative 1. So we would say this is inconsistent. It's an inconsistent system. Can't have it. Can't happen. Okay, so inconsistent, parallel lines, no solution. Okay. Yeah. So let's look at this one here. Let's solve it first, and then we'll maybe graph it and see what happens. So if I solve, well, really, it's not set up for elimination. My x's are all lined up, and that's nice. My y's, but there's this equal sign here in the plus, and that just doesn't quite line up the way I want it to. So I could line it up and use my solving by systems or by elimination, but I'm just going to get y by itself. Probably have to graph it anyways. Might as well get y by itself. So I'm going to try and get this y all by itself here. I'm going to add 2x to both sides. 2x. I get y minus 4 equals 2x plus 0, but we'll leave the 0 off. And then I'm going to add 4 to both sides. So my equation then, I can't move any further up, so I'm just going to go over here. My equation then is going to be y equals 2x plus 4. Now that I have that, well, we can either substitute that in. Sure, we'll do that. I see that y is the same as 2x plus 4. There's a y right there. So I'm going to write 4x equals 2, instead of y, 2x plus 4 minus 8. I can solve for x. I can distribute through the parentheses. I get that 4x equals 4x plus 8 minus 8. Well, let's see. 4x equals 4x. So I'm going to get my x's all together. Minus 4x from both sides. Minus 4x from both sides. I get that 0 equals 8 minus 8. Well, that's 0 equals 0. That's true, I suppose. But again, not necessary. And when you see something like that, it means that there is a solution, right? It's correct. We didn't have one of these where negative 2 equals 1. That's inconsistent. That's wrong. So there's no solution there. So what's going on here? 0 equals 0. We can't call it the identity because that doesn't apply for a system. So let's try and graph it. Let's see what happens. So I'm going to graph this first equation up there, y equals 2x plus 4. So I plot the y-intercept, or the y-intercept, yep, 4, slope of 2. Now I can't really go up 2 over 1. It goes off the graph. But remember that graphs, linear graphs, and linear lines go in both directions. So I can go, instead of up 2 and to the right 1, I can work backwards and go down 2 and to the left 1. Down 2 and to the left 1. Down 2. So it's still a positive slope. It would still get off the graph that way, but that's how we can work with a graph that's a little bit too small. The next one, y is not quite by itself in the second equation here, 4x equals 2y minus 8. I'm going to need a little more room, so I'm going to go down here. Lots of work when you're dealing with many systems. So we've got 4x equals 2y minus 8. Read that. So I'm going to get y by itself. I'm going to add 8 to both sides. I'm almost there. Got 4x plus 8 equals 2y. Divide everything by 2. You get that 2x plus 4 equals y. I'm going to graph that equation now. 2x plus 4 equals y. Looks familiar. Y-intercept 4, slope of 2. Oh, what do you know? It's the exact same line. So how many times do those two lines intersect? An infinite number of times. This is the exact same line. So they're parallel, but they're not two different lines. It's actually the exact same line written twice, which is redundant. It's like it's not necessary. It's almost like it's not needed to say 0 equals 0. It's the exact same line twice. So there are three different things that can happen here. You could have no solution. You could have an infinite number of solutions where it's the exact same line, they're right on top of each other, or they could just intersect once, like every other line we've looked at. So three different things that could happen, and here we are. So a consistent system has at least one answer. They're not parallel. There has at least an answer to it. Inconsistent, no solution. Consistent, there's at least one answer. If there is exactly one answer, like most of our problems will have one solution. That's called an independent system. And if there's an infinite number of solutions, like the one we just looked at, there's infinitely many solutions, we call that a dependent system. Lots of vocabulary in this section. We've got inconsistent, no solution. Consistent means there's at least one solution. So an independent system is consistent and it has exactly one answer. Those are the ones we like because it gives us something to work with. A consistent system that has an infinite number of answers is a dependent system. Lots to take in. I'm going to kind of give you a couple little hints here. If it's independent, remember, or excuse me, sorry, I'm screwing them up. If it's inconsistent, they're parallel lines and they're different lines. If it is dependent, it's the exact same line written twice. We had 2x plus 4 in blue, and down here in green, 2x plus 4 again. The exact same line is dependent. And if it's independent, there is an answer. What I'd like you to do is take a couple minutes, pause it, figure out for these four, is it independent? So one solution, dependent, an infinite number of solutions, or inconsistent? Inconsistent, no solution at all. If it is independent, if there is an answer, solve for that answer. All right, I'm assuming you paused. I'm assuming you tried it on your own. I'm just going to write the answers, and then I'll expect you to watch the linked videos or the videos beneath to see how to do it if you did it wrong. So the first one is inconsistent. There we go. That was horrible handwriting, but there's an N there. There we go. Inconsistent. The second one here is independent, which means that there is a solution and the solution is 2, 1. The third one down here is dependent. And the last one Last one is also independent. And if it's independent, there is a solution. The solution is 10.5, negative 15. So if you didn't get those solutions, make sure you watch the linked video.